Hey kids, it's Mrs. Butcher and this video is on inequalities. Okay, first we're going to start with some definitions. First one, linear inequality. It can be written in one of the following forms where a and b are real numbers and a does not equal 0. We can say ax plus b, so that's just a standard line, is less than 0. That would be an inequality. It could be ax plus z is greater, or ax plus b is greater than 0. We could say ax plus b, just some line, is less than or equal to 0. And we could say the line ax plus b is greater than or equal to 0. So inequalities are in one of those forms. A compound inequality is one that consists of two simple inequalities joined by either and or. The solution to an inequality is going to be a value that, when you substitute it for the variable, gives you a true statement. The graph of an inequality is all points on the number line that represent solutions. So we're not going to graph this in x and y, we're just going to graph it on a number line, and we're going to shade in all of the parts of that number line that can work as a solution. And our last definition is a solution set, which we have talked about. But when you're doing an inequality, it's a range of answers, and so it's written in brackets with a lower bound listed first, then the comma, and then the upper bound. We put soft brackets on it when the bounds are non-inclusive, and we use hard brackets when the bounds are inclusive. Okay, so here's an example. We have this inequality, 4 minus 2x, it's linear, is greater than 6. And we're doing this for reals. That's the domain of our answers. So basically anything except imaginary, which we're not going to do. Alright, so when we solve an inequality, we do it just like we would do an equation. We're going to subtract 4 away from each side. So we've got negative 2x is greater than 6 minus 4 is 2. Then we're going to divide each side by negative 2. And remember, when you do an inequality, you always switch the sign when you divide by a negative. So now we have x is less than negative 1. Alright, so all x's that are less than negative 1 will satisfy this original inequality. So we're going to graph our solutions on a number line now. And the way we're going to do that is at negative 1, we're going to put an open circle. And you can do it on the number line or you can do it above it. Sometimes it's easier to see if you do it above it. But it needs to be an open circle. And then we're going to shade everything that is less than that. So we're going to go to the left and put an arrow because we're going to the left. So this red ray here represents all of the solutions on the number line that satisfy this original inequality. And we're going to write it in set notation. So our solution we're going to say the lowest amount that it could be. If there's an arrow, that means it's going on down to negative infinity. So we're going to put negative infinity. Then we're going to put a comma, and then we're going to put the highest amount it could be, which is negative 1. And then if it is non-inclusive, we use soft brackets, which are basically parentheses. So we're not including negative 1. There's an open circle on it. And we're not including negative infinity. We never include the negative or the positive infinity because that's not actually a value that you could touch. And remember, because I see this all the time, write your solution from least to greatest. Alright, our next example, 8 parenthesis 2x minus 1 close parenthesis is greater than or equal to 11x minus 17, and this is for all reals. So first thing we need to do is solve this just like it was an equation. We're going to distribute the 8. We've got 16x minus 8 is greater than or equal to 11x minus 17. And then we want to combine like terms. So we are going to add 8 to both sides. 16x is greater than or equal to 11x, and negative 17 plus 8 is negative 9. And we're going to take 11x away from both sides, so we've got the x's on the left. 16x minus 11x would be 5x. 5x is greater than or equal to negative 9. And then we're going to divide both sides by 5. 5 is positive, so we don't switch the sign. X is greater than or equal to negative 9/5. So that is our solution, or that is our answer. We're going to graph that on a number line. All right, so negative 9/5 is almost negative 2, but not quite. So I'm going to put a closed circle right here, and I'm going to label it negative 9/5. And then we want greater than or equal to. That's why I did a closed circle, because closed circle goes with this little line under here. And greater than goes to the right, so we will shade everything to the right of that point. And that shows us on the number line all the x values that are greater than or equal to negative 9/5. Then when we write our solution, we're going to say the lower bound, the left bound, is negative 9/5, comma, and the greatest bound over here, there's an arrow, so infinity. It does touch negative 9/5, so we put a hard bracket on it. And then infinity we do not touch, so we put a soft bracket. All right, our next example, we have the absolute value of 2x plus 1 is less than or equal to 7. And a good rule of thumb for you to remember when you're doing these is just take the bars, turn them into parentheses with a plus or minus in front of it. So that means that I am going to do two problems. I'm going to take positive 2x plus 1 is less than or equal to 7 and negative parentheses 2x plus 1 is less than or equal to 7. Make sure you put it in parentheses so that you negate both parts of it. All right, solving the left side here, that's easy. We've got 2x, and then we're going to take away 1, less than or equal to 6. X is less than or equal to 3. On the right side, because we have to remember to include that as well, and we have to remember this minus sign, I'm going to just get rid of the minus sign. I'm going to divide both sides by negative 1, and I have 2x plus 1. And then when you divide by negative 1, you switch the sign, greater than or equal to 7. Negative 7. So I divided by negative 1, and I switched the sign. All right, now we're going to subtract 1 from both sides. Negative 7 minus 1 is negative 8. Divide both sides by 2. X is greater than or equal to negative 4. So we have two limitations here on what x can be. And we're also limited to the integers. So remember, integers are only the whole numbers. That means on our number line, we're going to have dots and not anything shaded in completely. So let's try that. All right, I made a number line, and I went ahead and indicated our important values on it, negative 4 and positive 3. So if we are less than or equal to positive 3, we're going to put a closed circle, and we know we're going to shade less than to the left. We're also greater than or equal to negative 4, so that's going to be a closed circle. Greater than is to the right. So now we would be shading everything in between negative 4 and 3, only don't forget you are limited to only the integers. So we're going to put a closed circle, a dot, on negative 3, on negative 2, on negative 1. 0 is an integer, and 1 and 2. So we have dots from negative 4 to 3. Make sure you pay attention to your domain limitations when you're graphing your inequalities. All right, so if we're going to write this as a solution set, this is kind of funny. You're not going to write it as a range from something to something else because it's actually these 1, 2, 3, 4, 5, 6, 7, 8 specific values. So we're going to just list those specific values. Remember, when you're listing them, you use the fancy brackets or the braces. From least to greatest, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Those exact numbers are the only ones that satisfy this inequality for all integers. Our next example says negative 5 is less than 2x plus 3 is less than 15 for all reals. So this is a compound inequality, and when you have a compound inequality, we need to make sure that we're treating it like it's an equal sign or here and here. Whatever we do to the inner part of the inequality, we have to do to both outer parts. So we're going to take away 3, and when I say from both sides, I really mean from all 3 sides, because you're going to have to take it away on this side, and you're also going to have to take it away on this side. So negative 5 minus 3 would be negative 8. Is less than 2x is less than 15 minus 3 is 12. And then we have to divide everything by 2. So we've got negative 4 is less than x is less than 6. So that is our compound inequality. On the number line, we're going to graph everything between -4 and 6, and since it's for reals, it'll be everything in between. At the -4, it's less than but not equal to, so I'm going to put an open circle. At the 6, I'm also going to put an open circle. And then x is everything in between. So we can just shade everything in between, or you can draw it up above like that. Either way is fine. When you write your solution, you're going to say the solution is the lowest value is -4, the highest value is 6, and since we don't touch either of those, it's soft brackets. Okay, our next example, we've got x plus 7 is less than 4, or 7 minus x is less than 1. So that's a compound inequality, and we're doing this for reals. So we're going to just solve each one. We've got x is less than 4 minus 7 is -3. And then we have negative x is less than 1 minus 7 is -6. And then we need to divide both sides by -1 and switch the sign. X is greater than 6. So we have two parts to this. When we put it on the number line, we're going to have two different parts that we draw. We have x is less than -3, so we're going to put an open circle at -3, and then less than is left. And we have x is greater than 6, so we're going to put an open circle 1, 2, 3, 4, 5 at 6, and greater than goes to the right. So we have two parts to this. And then when we write our solution, you're going to do a soft bracket and -infinity. And then the right-hand side of this is -3. It doesn't touch it, so you put a soft bracket. And then you're going to do another soft bracket because this is also open, 6, and then infinity on the right there. You have to do it from least to greatest. And sometimes you can put, you might see a U in between, U for union, 6 to infinity. The U is not required. If you like it, put it. If you don't, don't. But just if you ever were to see that, that's all it means. And this is called a disjunction. And our last example is going to be the absolute value of 3x minus 2 is greater than or equal to 4x. And this is for integers. So we have two things we're going to cover here. We're going to cover what to do with an absolute value, and we're going to cover what to do when it's integers, which I think we already talked about. All right, so like I said before, you turn your bars into plus or minus parentheses, and then you solve it twice. Oops, sorry, plus or minus parentheses. So I'm going to take 3x minus 2 is greater than or equal to 4x. But I'm also going to solve minus 3x minus 2 is greater than or equal to 4x, like that. So for this first one, I'm going to combine like terms. I'm going to just, let's see, we will subtract 3x from both sides. So we've got -2 is greater than or equal to, and 4x minus 3x would be 1x. We can rewrite this as x, and then the small side is still pointing to the x. X is less than or equal to -2. And then on this other side here, you can either divide both sides by the negative immediately and switch the sign, or we can just apply it. We could say -3x, and then minus 2 becomes +2. Either one of those methods would be okay. Then when we combine like terms, we're going to add 3x to 4x, so we have 2 is greater than or equal to 7x. And we're going to divide both sides by 7, sorry. So if we wanted to get the x on the left, because that's standard, then the sign is pointing to the x. X is less than or equal to 2/7. And now we need to put that on the number line. All right, so we want x is less than or equal to 2/7. 2/7 is just a little bit more than 0, so, somewhere over here. We only want to shade the integers that are less than 2/7. So we're not going to put anything at 2/7. The next lowest integer is 0, so I'm going to put a dot on 0. And then -1 is lower, and then -2. And we're going to shade all the integers on down. And the way I indicate that I'm going to continue going down is I'm going to shade the arrow. right here. Maybe highlighted that in your notes. So that implies that we keep going, all the integers down. And when we write our solution, s equals, and we put fancy brackets because these are specific individual numbers, we're just going to go negative infinity, dot, 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 and then we'll list them. -2, or -3, -2, -1, 0, and close it. So when I do that, that implies that it's all the integers all the way up to 0. And that is our last example. That's the end of the video. I'll see you guys tomorrow. Bye.